Imagine a world, but not like any world we know. A planet adrift in the vast, unyielding blackness of space, far from the nurturing warmth of a sun. It's a world without a star, a lonely planet drifting through the cold emptiness of the cosmos, completely untethered to any solar system. No glowing orb hanging in the sky to mark the passage of time. No sun to provide warmth, to create seasons, to make life possible. A cold, desolate place, yet a planet all the same. This is the reality of rogue planets, enigmatic wanderers that exist without a sun to call their own. They defy everything we once thought we knew about planetary systems. These planets aren't simply rare, they are cosmic outlaws, drifting through space without allegiance to any star, making them some of the most mysterious and fascinating objects in the universe. What would it be like to stand on one of these worlds? Would it be a silent, frozen wasteland, or could it harbor unexpected secrets? Could life survive on such a planet? Or are rogue planets as empty and inhospitable as they seem? Today, we embark on a journey to understand these solitary, starless wanderers, rogue planets, and the profound mysteries they hold. Rogue planets are planets that do not orbit any star. At first glance, they might seem like misfits, cast adrift in the great cosmic ocean. These planets aren't tethered to a solar system. They don't follow the predictable orbits of planets we know, like Earth orbiting the Sun. Instead, they drift freely through the infinite expanse of the universe, moving along trajectories that are entirely independent of any stellar system. While we are familiar with the idea of planets circling stars, rogue planets remind us that the universe doesn't always play by the rules. They are the true loners of the cosmos, planets without homes, wandering through the void of space. But where do they come from? How did these planets end up alone, far from any star, and how can we begin to understand them? It's a question that scientists have been working to answer for decades. The discovery of rogue planets challenges everything we thought we knew about the formation and evolution of planetary systems, and it opens up new possibilities for the nature of life and habitable worlds beyond our solar system. Rogue planets begin life much like other planets, by forming from the leftover material in a young, chaotic star system. In the early stages of a solar system's development, gas, dust, and ice swirl together, coalescing into planetesimals and eventually planets. Most planets end up in stable orbits around a star, but some don't. Some are destined to be cast away. One way rogue planets are created is by forming too far from their star. In these cases, they never get close enough to be captured by the gravity of a parent star, and instead, they wander the emptiness of interstellar space. They are born far from the warmth of the star, in what we call the frost line, where ices can condense and form icy bodies. These planets remain independent, floating through the universe without the gravitational influence of a sun. But there's another way rogue planets come into being, through a violent process known as gravitational ejection. Imagine a young solar system teeming with growing planets. These planets are in constant motion, interacting with each other as they form. In some cases, a particularly massive planet, like Jupiter or Saturn, can disrupt the orbits of smaller planets, sending them hurling out of their orbits and flinging them into the vastness of space. These ejected planets are no longer bound by the gravity of their parent star, becoming rogue planets. In fact, many rogue planets may have once orbited distant stars before being catapulted out of their solar systems. In this way, rogue planets are not necessarily born isolated, but are often products of cosmic violence, shifting, colliding, and falling into a state of wandering loneliness. What is it like to be a rogue planet, adrift in the cold, dark reaches of space? Without the light of a nearby star, these worlds are plunged into eternal night. On their surfaces, temperatures can plummet to hundreds of degrees below freezing. There is no sunlight to warm the land or create the familiar cycle of day and night. The winds, if they exist, are silent, whispers in a planet that has no connection to any sun. But does that mean these planets are completely devoid of life or interest? Is the cold emptiness all there is? Or is there more to discover? On Earth, life depends on the energy from our sun, but rogue planets may hold unexpected surprises. Though they lack sunlight, some rogue planets may harbor hidden energy beneath their icy crusts. The heat from a planet's core, geothermal energy, could provide the necessary warmth for subsurface oceans to exist, much like the hydrothermal vents at the bottom of Earth's oceans that support entire ecosystems. Could life thrive in these hidden environments? Could alien life be thriving beneath the frozen surfaces of rogue planets, in the dark depths of worlds that no one has ever seen? Furthermore, if a rogue planet has moons, those moons could provide another possible refuge for life. These moons could experience tidal heating, the gentle but powerful forces created by the planet's gravity pulling on them. This process can generate warmth and possibly create the right conditions for life to take hold. Imagine a moon orbiting a rogue planet, where oceans might exist beneath a thick, frozen surface, heated by the planet's internal processes. It might not be the Earth we know, but it could still be a world where life finds a way to survive. For years, rogue planets were nothing more than a theoretical concept, distant, hypothetical objects that scientists speculated might exist. They were invisible to the naked eye, and without a star to shine light on them, they were nearly impossible to detect. But with new technology, we are beginning to glimpse these hidden worlds. One of the most effective tools astronomers use to detect rogue planets is microlensing. This phenomenon occurs when a rogue planet passes in front of a distant star, its gravity bending and focusing the star's light. This brief, detectable increase in brightness is the planet's calling card, allowing astronomers to spot it even though it doesn't emit light of its own. It's as though the planet is casting a shadow of light, on the stars of the universe. In addition to microlensing, astronomers have developed methods to detect the faint heat emitted by rogue planets. Although they don't receive any energy from a star, rogue planets can still retain heat from their formation or generate internal warmth. This heat escapes into space as infrared radiation, and sensitive telescopes are now able to detect these faint glows, allowing scientists to identify and study these dark wanderers in more detail. The discovery of rogue planets is changing the way we think about planetary systems, the potential for life, and even the future of human exploration. These lonely worlds challenge everything we once believed about how planets form and how they survive. They represent a new frontier in our understanding of the universe. Could these rogue planets be homes to hidden civilizations, worlds where life took a different path? Could they hold resources or mysteries that we can't yet imagine? And perhaps most intriguing of all, what does the existence of rogue planets tell us about the nature of planetary systems and our own place in the cosmos? Though it may seem like a distant dream, the exploration of rogue planets is not beyond the realm of possibility. As we look toward the future, the technology to explore these starless worlds may become a reality. With spacecraft capable of interstellar travel, one day we may be able to visit these lonely planets, studying their surfaces, their atmospheres, and their potential for harboring life. Perhaps rogue planets could even become humanity's new home in the distant future. If the stars that warm us today eventually burn out, could these lonely planets, drifting in the vast silence of space, become our refuge? The possibilities are endless.